All right, today we're going to go on a journey to the absolute edge of what we know, to the biggest, most mind-bending questions that physicists are tackling right now. And really, this is the question that drives everything we're about to talk about. From the tiniest, fleeting flicker of a subatomic particle all the way up to the epic cosmic scale of the entire universe. There are these deep, profound mysteries just waiting for us to solve. So, let's start with the smallest things imaginable. If you want to understand everything, you have to start with its parts, right? We need to find the ultimate, the most fundamental, indivisible building blocks of reality itself. For about the last 50 years, our guide on this quest has been the standard model of particle physics. The best way to think about it is like a cosmic recipe book. It lists all the fundamental ingredients, particles like quarks and electrons, and the forces that tell them how to mix and interact. And this thing is incredibly successful. It predicted the existence of particles like the Higgs boson with such stunning accuracy. It is hands down the most successful scientific theory we've ever come up with. But here's the catch. For all its success, our amazing recipe book has some major missing pages. It has absolutely nothing to say about the mysterious dark matter that we know is holding galaxies together. It can't explain why there's a universe full of matter and almost no antimatter. And, oh yeah, it completely leaves out the force of gravity. These aren't just little footnotes, they're giant gaping holes in our understanding of reality. So what do? We have to look for physics beyond the standard model. And that's exactly what's going on at these massive experiments like the Large Hadron Collider. They're basically just smashing particles together at insane energies, hoping to see something new. Maybe a rare particle decay, or a tiny, tiny deviation in the behavior of the Higgs boson. Anything that could be the first crack that leads us to a new, more complete theory. Okay, so discovering the fundamental rules of the universe is one thing, but what about using them? That brings us to a totally different frontier, the wild world of quantum technology. So, quantum computers, they hold this incredible promise to solve problems that are literally impossible for even the biggest supercomputers we have today. But there's a huge catch. The building blocks of these machines, these qubits, are unbelievably fragile. The slightest little vibration, a tiny change in temperature from the outside world, and poof, it loses its quantum magic and just acts like a regular computer bit. It's a massive problem called decoherence. So how in the world do you build a reliable computer out of unreliable parts? Well, the solution is pretty ingenious. It's called quantum error correction. Instead of relying on one super fragile physical qubit, you encode the information across a whole team of them. Together, they act as a single, much more robust unit, a logical qubit. The system is constantly running around, checking for errors in the team and fixing them on the fly. This is the key to building truly fault-tolerant quantum computers that can actually do useful work. And with that kind of power, physicists could do something amazing. They could simulate the quantum behavior of complex materials with perfect accuracy. Think about what that could unlock. New types of superconductors, revolutionary medicines, new catalysts that could completely change our world. We're on the verge of moving from just computing to truly simulating reality. All right, so we've looked at the very small and the very powerful. But physics isn't just about fundamental particles. It's also about how those beautifully simple rules can give rise to the incredibly complex and, yeah, sometimes chaotic world all around us. The principles of physics pop up in the most unexpected places. It turns out the same math, the same statistical mechanics used to describe how gases behave can also be applied to financial markets or the flow of traffic on a highway or even the complex machinery inside a biological cell. Physicists are finding the hidden order in systems that just look completely random, like turbulent plasma, which might actually help us figure out where the most energetic particles in the universe, these things called cosmic rays, are even coming from. This brings us to our final and maybe the grandest frontier of them all. What happens when we zoom out, as far as we can possibly go? And here, the questions are just as big as the universe itself. We're talking about the fundamental nature of space and time, the origin of everything, and oh yeah, the 95% of the cosmos that we can't see at all. Get ready for this because it's kind of mind-blowing. Everything we see and touch, every star, every galaxy, every single person, makes up only 5% of the universe. Just 5%. The rest is made of dark matter, this invisible scaffolding that holds the cosmos together, and dark energy, this even more mysterious force that's causing space itself to expand faster and faster. We know they're there, but we have almost no idea what they actually are. So to find answers to these cosmic mysteries, scientists are doing something different. They're not just looking with traditional telescopes anymore. Now, they're listening. listening for faint ripples in the very fabric of space-time. They're listening for gravitational waves.
And in 2023, they found something astonishing. An experiment called nanograph detected this constant, low-frequency background hum of gravitational waves washing over our galaxy. But here's the kicker. This hum is way, way louder than our best models of supermassive black holes smashing into each other can explain.
This is one of the hottest new mysteries in cosmology. Something else is out there, shaking the universe, and we just don't know what it is. Is it some exotic process left over from the Big Bang? A new type of cosmic object we've never imagined? The race is officially on to figure it out. And even our absolute best theory of gravity, Einstein's general relativity, isn't perfect. It completely breaks down at the center of a black hole and at the very first moment of the Big Bang. At these places, called singularities, our physics just stops working. The math gives us gibberish, which is the universe's way of telling us there's a deeper theory, a theory of quantum gravity that we still have to find. So, as you can see, these frontiers are all interwoven. The mysteries of the quantum world are deeply tied to the ultimate fate of the cosmos. The behavior of complex systems right here on Earth can echo the dynamics of plasmas in distant galaxies. It really is all one grand interconnected puzzle. And that leaves us with a final thought. Unlocking any one of these secrets, finding a new particle, building a real quantum computer, or figuring out what dark energy is, that won't just be another discovery. It will fundamentally change our story and our place in the cosmos. The only question is, which one of these frontiers will be crossed first?